So this lesson will be on segment and angle addition. We're going to go over these postulates, how to apply them to problems, and how to also apply them to proofs. So the first postulate is segment addition postulate, and it says that if point B is between A and C, so between A and C, then AB plus BC equals AC. So basically what we're saying is that if we have a segment AC which is broken up into two smaller parts, then I can add up those two smaller parts and have it equal to the larger segment. So that's segment addition. Then we also have angle addition, which angle addition postulate says that if point S is in the interior of PQR, so we have angle PQR and S is a point in the interior, then the measure of PQS, so this top little angle, plus the measure of angle SQR is this bottom angle, equals the measure of PQR, the larger angle. So in other words, if we take the two smaller parts of the angle and add them up, we will equal the larger angle. So there's some similarities between these two postulates, except for one we're dealing with segments, the other we're dealing with angles, but both of them are talking about taking two smaller parts and adding it up to equal the larger segment or larger angle. So now we're going to apply these postulates to solve some problems that involve equations, setting up equations. And just like any other example that I've told you, we need to write down these examples. This is important, and we're going to be doing problems like these on our own. So I want to work on setting up an equation using a relationship between these two segments. So using the segment addition postulate, I know that if I add up these two segments, I can set it equal to the whole larger segment, which down here they're showing us that the whole larger segment is 9. So my equation would be to add up x minus 8 plus negative 5 plus x and set it equal to 9. So here I have set up that equation, and then I just went through solving to find out what x is. So I combined my two x's, and that's how I got 2x. I combined my negative 8 and negative 5. That's how I got negative 13. Then I added that 13 to both sides to do the opposite and cancel this negative 13. I got 2x equals 22. And then the last step I divided by 2 to both sides and got x equals 11. So I now found out what x is, but notice it asks you to find FG. So that we want to find the length of FG. So now that I know x, I can plug it in to find FG. So since FG was equal to x minus 8 and x is 11, I can plug in 11 minus 8 and find out that FG has a length of 2. So now we're going to see the application of the angle addition postulate. Sometimes we'll have our measurements just listed out, and so what I like to do when we have this, and I highly recommend you doing this too, is just start to label these measurements on the diagram or make your own diagram. So it says if find the measure of NML, so find the measure of the whole big angle. If NMA is 20, so NMA right here I put in red is 20 degrees. AML is 21x plus 8, so AML I put in green right here is 21x plus 8. And NML, the whole entire segment, NML, is 26x plus 7, and I just drew a little arc here to show that that's the whole entire angle. So similar to what we just did in the last problem, we need to take the two smaller parts of the angle and add it up, set it equal to the larger angle. So my equation becomes 20 degrees, so right here, plus 21x plus 8, which I got from here, so the two parts of the larger angle, equals 26x minus 7. So right here, 26x minus 7 is the whole thing. So then I go through solving. So I'm combining my like terms. So 20 plus 8 is how I simplify to 28 here. So 21x plus 28. Then I want to consolidate all my numbers on the same side. So I will add 7 to cancel my negative 7, move it over to the other side, and I get 21x plus 35 equals 26, what I had left on this side. Then I want to get my variables over to the opposite side. So since I moved my numbers here, I'll move my variables over there. Subtract 21x to both sides, and I get 35 equals 5x, and then I divide by 5, and 35 divided by 5 is 7. So if we go back up to the problem, it says to find the measure of NML. Now, the measure of NML is right here. It's my 26x minus 7. So now that I know what x is, I can find the measure of NML. So I've done that right here. The measure of NML is 26x minus 7. Ooh, I plugged in the wrong number. So instead, I want to, let me fix that, plug in 7 right here. So 26 times 7 is 182. So let me fix that. Should have 182 here. And then 182 minus 7 should be 175. So the measure of NML is 175. Okay, so now we're going to see this in a proof, and I just want you to bear with me and, try to understand the proof. We're going to involve these new postulates. We're also going to involve some algebra, so some of the algebraic properties that we've been using. So we are given that HGK is equal to the measure of JGL. So we are told that these two angles are congruent. And we're trying to prove that the measure of angle 1 is congruent to the measure of angle 3. So we do have some overlapping here. And so we're going to have to involve some algebra to take out this overlap. So we can always start with the given. So the given statement is that measure of angle HGK equals the measure of angle JGL, and that's given. We can always end with the prove statement, which I have down here at the bottom. The measure of angle 1 equals the measure of angle 3. So we're going to figure out the middle. So the next statement that I've written is I want to just look at the measure of angle HGK and what it is made up of. So this red angle right here is made up of angle 1 and angle 2. The green angle GJL is made up of angle 2 and angle 3. So what I've written out here is that HGK is equal to the measure of angle 1 plus the measure of angle 2. So 1 plus 2 makes up HGK, the red angle. And then I've also written that the measure of angle 2 plus the measure of angle 3 makes up angle JGL, which is the green one. The reason that I know this is the angle addition postulate. I've just added up the halves of the two angles. So what I'm eventually trying to get to is have angle 1 equal to angle 3. So somehow I want to put them together in an equation. So I always have to be using something that I've stated before. So what I notice here is that I've already been told that HGK and JGL are the same, which is right here. So if I'm saying that these two are the same, I'm trying to get to saying that these two are also the same. So what I've done next is say that the measure of angle 2 plus the measure of angle 3 equals the measure of angle HGK. So I already knew that HGK was 1 plus 2, but since 2 plus 3 is equal to JGL and these two angles are the same, I can now say that 2 plus 3 is equal to HGK. And this is substitution. So I've taken this equation right here and I've substituted to get here. So I've used substitution, replaced JGL to get that substitution here. Okay, so we'll keep going. So now that I've said HGK is equal to both of these equations, 1 plus 2 and 2 plus 3, I can put those together. So the next thing that I can say is that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. So look at these two equations I have right here, and they both were equal to HGK. So HGK is like my middleman or my link, and that would be the transitive property. So since they were both equal to the same thing, I could take out that thing in the middle and put them equal to each other. Transitive property. So I have one step left to get to here. And if I look at this equation, what do I need to get rid of to get to my next step? What I need to get rid of is the measure of angle 2, which is on both sides of the equation. Now I know that I can take something out as long as I take it off of both sides of the equation. Since the measure of angle 2 is being added on both sides, I'm going to subtract to get it out. And so my last reason to get to my conclusion is the subtraction property of equality. I will subtract measure of angle 2 on both sides, and that's what allows me to get rid of it and, essentially cancel it out. I can get rid of that and get rid of that and just be left with the measure of angle 1 equal to the measure of angle 3. Now, if there's questions that you have about this proof, right at the second, I would like you to jot them down or maybe circle the part of the proof that you don't understand so we can get some clarification on it in class. Okay, so we do have one more proof to do, and it's involving segments. Alright, so a good place to start is, again, marking on the diagram. So I am given that EF is equal to GH, or that those parts are congruent. Remember to mark congruence on a segment, we put a little tick mark. So EF is congruent to GH, so I know those parts are the same. I'm trying to say that EG is congruent to FH. So I have EF is congruent to GH, and I'm trying to say that EG is congruent to FH. So notice that both of them have this little part in the middle. And that's really the only difference between these two segments right here. So eventually, if I have this on both sides, that's going to help me because this really is the same segment. So we start out with our given, we end with our proof, and then we're trying to fill out in between. So the first thing that I'm going to say is use my segment addition postulate, and I can say that EG is equal to EF plus FG. So just saying that these two parts equal EG. At the same time, I'm going to say that FH is equal to GH plus FG. So I really am just saying